Happy Friday, YouTube. What's up, everybody? This is Greg from Greg's Tutoring NYC. How's everybody doing out there? So you guys are, at least in New York City, you're done with your first week of school. Yay! All right. Um, I'm just noticing now I have on a black shirt. Looks like I'm a floating head. All right. So floating heads are good too. Um, I just had a session, got messed up from 5 o'clock, so I'm going to do about half an hour here, maybe 45 minutes at most. So we're going to just jump in on this part 5 of the grade 7 hardest problems. Um, this set of problems looks a little better and a little deeper. Let me just make sure we're live here. Floating heads are good too. Okay, we're live. Okay. Um, Welcome, everybody. Please like and subscribe. And what I'm going to do is I'm going to jump right into this stuff today. All right? No banter whatsoever. So 3 friends. Let me get the tab going. And this set of problems seems a little deeper than normal. So it's a good set of problems. It's actually nice for students taking the SHSAT, the ISEE, the SSAT, the TACHS, the Hunter College High School test. These are a little meatier, a little deeper. I wouldn't say they were hard per se. So 1 or 2 might be hard. There's a few gotchas with percents. So those are kind of SHSAT flavored questions here. And they're only grade 7, so that makes it more interesting. Although theoretically / technically, that's the grade that the SHSAT 8 is on. SHSAT 9 is supposed to be based on grade 8. We know that's not really quite the truth, but let's go in here. 3 friends own a landscaping business. Cool. Awesome, dude. The number of hours each friend spent on the same project is shown in the table below. So as I said, I don't like to look at the table by itself first. So hours worked on a project. Okay, there's 3 guys, 1, 2, 3. That's three friends is talking about apparently. And Edgar worked 17 and a quarter, Kelly 18 and a quarter, Sean 14 and a half. So I kind of like to look at these and start trying to make sense of them. Since these, so it looks like, let me just try to get min and max. Kelly's the max, Sean's the min. I might try to total these up. So I'm going to get a quarter, and a quarter is a half plus a half. So the fractions is 1s, right? And then we have 15, 19, 1, 3, 4. Okay, this looks like it's equal to 50. So since I actually totaled that, let me make sure that actually is what it is. So I'm going to add it up a different way. Let me see, 17 and 18 is 35, plus 10 is 45, plus 4 is 49, and again a half plus a quarter is 1. Yep, so they add up to 50. So what I like to do is when I see a number like 50 popping out here, so that's the total of all their hours, I like to think, that's half of 100, okay? Or double it is 100. Is somehow that involved in this? It's a nice smooth number. Like 18 and a quarter and stuff is not nice. I consider them ugly numbers, but 50 is kind of a nice smooth number. So maybe that's something that's going to come into play here. Maybe not. Maybe I'm jumping at shadows. But what you do is when you get used to these kind of problems, certain things start leaping out at you that you're going to try to take advantage of. Even if it had nothing to do with this, most of us like to work with multiples of 10 and stuff like that. So let's see where this can go from here. So it's their name, the hours worked. There's really nothing else we can grok here, except for getting like, there's not, unless it asks us like how much did Edgar and Kelly make hours worked by themselves or something. So let's go back. 3 friends own landscaping business. Cool. The number of hours each friend spent on the same project is shown below. Cool. So that all makes sense to us. So I don't really need that initial sentence here, so we can try to fit the rest on the screen right now. So in total, they earned $850 for a job. Okay, they put so that's it. Okay, they put 15% of this amount in a joint savings account for future expenses. So I would stop then. Again, I don't know what the question is. So if I was really doing this on a real test, I would still stop then, but I wouldn't necessarily do the computation I'm about to do. I'm just doing this for kind of analysis completion's sake. So 15% of 850, you can do that by doing 850 times 15%. Okay, and we can get whatever that is. So to me, that starts getting ugly because I have to do 85 times 15 and then add a 0 to it. Okay, but what I can do is get 10% of 850. We're just taking kind of a little sidebar here that may or may not be involved. So 10% of 850 is $85, which means 5% is half of that, right? So it'll be 2 goes into 8 4 times, carry the 1, 2 goes into 15 7 times, and we'd have an 85.0, so we get 47.5. Okay, and now if we add the 2 of those, we get 0.5 here. 7 plus 5 is 12, 2. Let me make my 2 neater. Carry 1, 8, 9, and I get, it looks like 127, is it? 127.50, I believe. Let's just throw up a calculator to make sure I did that right. Something, my spidey sense is going off, kind of indicating to me that I made a mistake. So we're going to get, what are the numbers again? 850. Whoops, I'm not in the right application here. 850 times 0.15 is 127.50. Okay, so I did get that right. Where's my screen here? That was a 7. Yikes. Come on, erase. Why are you not erasing? Okay, I don't know what happened there. It's not erasing it. So we're just going to put 127.50 there. So now what we need to do is take that away from the 850, right? So if we were to do 850 minus 127.50. We have to add a 0 here, so we get 8.0. We can do a subtraction. What are we going to get? We're going to get 49 there. Add a 1 here, we get 5. And it looks like we're getting, is that 722? Not sure. I did this calculation on a piece of paper. And then it says, then the rest is divided. Then they divided the rest proportionally based on the number of hours they worked. Okay, by proportion means there's 3 of them. They didn't divide by 3. They divided by the percents. So this, and then they're asking how much money did Sean receive. So Sean got 14.5 out of 50. So if it's by proportion, then we can do that by percent. So we got watt out of 100 then, right? Because then we can take his share out of it. And all we have to do, because this is times 2, is just double this. We don't need to go through 100 14.5 times 100 and then divided by 50. Just we can see that's 28 plus the 2 halves, so we get 29. All right, so this ends up being 29%. Okay, so if you look at the answer choices, it should kind of leap out at you at this point that A and D are just, they just can't work. They're just too large. So then we're stuck with these here, right? So, and then when you do the computation, you're going to end up getting, actually, sorry. The answer is A. The answer is A. When you actually do those subtractions and divisions, that's what's going to end up kicking out. All right. There was another way to approach this, which is to take the 850. And instead of getting the 15% and subtracting it off, just get 85%. Okay, and then we're going to get Sean's thing. So his is 29%. Okay, and when we do that multiplication out, we should end up getting the same value there. Okay. All right. Okay, so that's the first example there. Whoops, that's the end of that line. So while I'm scrolling, again, I'm Greg from GregsTutoringNYC at gmail.com. Please like and subscribe. I'm doing a whole bunch of these. Probably going to go maybe 25, 20 more minutes. So we may not do as many today, or let's see if we have some simpler examples. Because some of these were harder, and I also remember some were simpler, conceptually harder. So that doesn't mean the problem itself required a lot of details to it. Is this the first one? Yeah, there we go. All right, so this is involving coordinate geometry. So it's telling us which ordered pair in the choices down here could represent the coordinates. There's really nothing to look here. There's 2, 4, 6, 8, whatever, 2, 4, 6, 8, whatever. It's going by twos, big deal. So we have 6, 0. That's A. We have 2, 3. That's B. Okay, we have 1.50. That's here. That's C. And then we have 7.5, comma 5. So this is 7 here in the middle, and then about 3/4 is 7.55. So 7.55 is going to be about right there. That's not the center. It's slightly moved over to the right, so that's D. Okay, so let's just reread the question. Line KN represents a proportional relationship. So that's the key to solving this. Point N, so this is on 18, 20 then here, right? We can go up 18 and go over 12. 18, 12, sorry. So that's that, as shown on the graph below. So line KN represents a proportional relationship. That means because we have an X and a Y, they're somehow in proportion to each other. Okay, and if you analyze it, X is equal to, well, it depends how you look at this, but X is equal to 1.5 of y. Okay, we can also flip that. This is the same as 3/2. So y is equal to 2/3 of x. Okay, so that's what the proportional relationship is telling us about. Okay, so we can have various things going on. So if any one of these points was supposed to represent a proportional relationship, then this must be true, either this or this. Okay, so which of these points seems to be that? It certainly doesn't seem to be A, B, or C. So it's D, right? So that x is 1.5 times that, or it's 3/2 of the other one, depending on whether we're looking for x or y. We can also prove it, because if we do this, let me see if I can figure this out. Wait a second, that's a line. Does this work if I do that? No, wait, let me see if I can figure this out again. Oh wait, here we go. It delayed for some reason. 1 second. We're sparing technical difficulty. All right, let me try this one more time. Set up the line. I don't know why it's putting that blue dot right there. Okay, there we go. Whoops, this dot should be moved over here. I don't know if it's going to let me move it at this point. Ah, no, it's not. Okay, there we go. All right, so you can see that. Whoops, I got to go back to the pen. I may have just screwed that up. See that this is the only dot. Point T is the only dot where it's there. Okay. In fact, the proportional relationship, if you're plotting it, that line has to go through 0, 0. So right there. All right. So that's another way to have tested it. You could have drawn a mock line there, freehand, and figured out which was closest to it, and then from those. But you still need to get one of these relationships right here. Okay. The problem with some of the other points, let's just say the point was here, it might go like this. Okay, and that has an offset. That has a y-intercept. So you're never going to get a proportional relationship out of that. All right, so you guys have to be careful with that. Let me just double check we're live. I see some people in the audience there. Welcome. Please, you're allowed to ask questions. I'd love this to be interactive. All right, let's try to skip to the next because I'm running out of time. I'm going to either end this at 6 or 6:15. So we're going to go another half an hour. Let me see if there was a question underneath there. No, there wasn't. Okay. Okay, for instance, the arrow here, since that goes through 0, 0, and it's a line coming out from there, and it could extend past, actually. Let me just line this up first. So there's this line. Could have kept going, but the fact that that's here, this is representing a proportional relationship. So Maya uses blue and orange fabric to make identical wall decorations. And by the way, we're going to look at this. So it's moving, every tick is 0.1 on the X, which is orange, and every tick on the left is also 0.1, which is the blue fabric, in yards. So 0.6 is 0.6 yards. Okay? So there's some sort of relationship there. For instance, if you looked at 1, if we do the dot here, we have about 0.4, well, that's 0.45. So we have like 0.43 where it matches. So it'll be 1 comma 0.43 or something like that. Okay. There's really nothing else going on here that we can kind of make sense out of. So my use is blue and orange fabric to make identical wall decorations. The graph below shows the relationship between the amounts of blue and orange fabric used. And again, this is a proportional relationship. What is the constant of proportionality as shown in the graph? Now what the heck are they talking about, right? So we were talking about before that we really need to end up with something like y equals something x. Right? If we go back to the previous example. Oh man, my voice is giving out and I have another session after this. So if we work from that, how about this something is m? Perhaps it's the slope. It's the slope, right? Because we have mx plus b. The y-intercept is 0. So the b actually gets thrown away. So we don't need that. Okay? So that turns out to be what the constant of proportionality is going to be. Because we're gonna go and bend that thing back and forth. Okay? Whether the slope is higher or not. Okay? So all we have to do is figure out where one of these crosses right where the two things intersect. So the only place I can see that, or the easiest way to do that, is right there. At that 0.7, 0.3. So we get 0.7 over 0.3. And that's the constant. If we simplify it, we get 7/3. Right? We can multiply them both. We could leave it that way, but that's not one of the answers. That turns out to be C. Whoops, I said it backwards. So it's your rise over your run. And that's the same as your change. This is normally spoken of as delta. Delta y, the change in y, over the change in x. All right, so y goes from 0 to 0.3, and x goes from 0 to 0.7. Okay, and the only one matching that in this case is going to end up being C. All right, so that's that one. That looks nasty, but that wasn't one of the hardest problems. Not sure why. Okay, so we have what looks like a word problem and an illustration. So it looks like somebody's backyard. The shorter side is normally called the width. Doesn't have to be. This is then the length over here, and this is also the length, and then therefore that's the width. Okay, and most likely when you have something like that, you're going to get an area. Okay, the area equals the length times the width. That's most likely it. There's a dotted line here and an X. So my guess is they're going to ask us for the length of X. Or maybe the area still. So what we also need to do is the perimeter. So the perimeter of this rectangle is going to be 2 times the length plus 2 times the width. Right? We have length plus width plus length plus width. And again, my L here is X plus the 60. So I don't know what else we can get out of there because I'm doing speculative thought now. So Keisha installed a fence along a 200-foot perimeter of her rectangle backyard. Okay, she left an opening for the gate, so there's nothing there. In the diagram below, right? We're going to end there. She used X to represent the length and feet of the gate. What is the value of X? In other words, how wide is the gate? Well, it seems to me that if the perimeter is 200, right? Wait, that should be equals. We're going to have twice the length plus, we know the width is 30, so that's going to be 60. Right? So that means 140 is equal to twice the length. Okay? That means if we divide both sides by 2, the length must be 70. We also know that X plus 60 is the length. So we end up with X equals 10 if we subtract 60 from each side. And we can double check it. If this was 70, right? 70 plus 30 is 100. And we have another 100 here, that's 200. All right? And if that's 70 and this is 60, then X must be 10. So it all jives. We lived happily ever after. Okay, 45 gets into one of those ones that's kind of messed up. So last year, 950 people attended the parade. This year, 1,520 people attended. What was the percent increase in attendance from last year to this year? So it seems to me that if we map that to math, that 950 times whatever that percent is, so we're going to call that X percent, is or equals 1520. All right? 900 people attended last year. There was a percent increase of a certain sort. And then this year it was 1520. All right? So X percent is the same as X over 100. Because anything percent is X is over 100. So we get 950 times X over 100 equals the 1520. So now we're just left with a regular solve the X problem. So we can multiply both sides by 100. This kicks out, and we add on 2 more zeros. Right? That was a 0 there, not an 8. And then to get X by itself, we're going to divide both sides by 950. Okay, I can get rid of this 0 here, and that 0. So we have two kind of ugly numbers still. We still have 1520 and 950. So we kind of got to sweat that out and do 95 and divide that into 1520. And I'm saying 1520, but it's 15200. My throat's giving out. I might actually stop after this problem. So if my numbers are correct so far, 95 goes into 1, can't do. 95 goes into 15, can't do. 95 goes into 152. Can't do it twice because that's like 190. So we can only go in once. We're going to subtract 95 from that. So this is where you need to be careful, myself included. I'm doing a live stream. So this is the point where I end up doing something stupid. So I can't do that. This has to be a 4. That becomes 1. This is 7. And that was at 5. And 95 goes to 57, can't do. I can drop down to 0. That's about 100. 100 into that is about 6. Wait, could it be 5? Let's try 5 first. No, 5 times 5 is 25. It can't be 5. It has to be 4 or 6. So let's try 6. 6 times 5 is 30. 0, 3. 54 plus 3 is 57. And we get it, 160. Okay, so x is equal to 160. 950 times 160% is the 1520. So it's asking us, what was the percent increase in attendance? Well, this is 160%. All right. Basically, what we need to do is the old value minus the new value, right, over the old value. That's basically what we did here. Okay. So it's going to turn out to be 60, which is C. If I got 160, it's 60 because it increased. It's the original whole thing plus some more. If you remember the other streams we did, that's exactly what we did there. So 100% is 1. So we need to get rid of the 100%, 100 over 100, and we're left with the 60. All right. Let me see if it's a real fast one here. Otherwise, we're going to call it a day. Okay, sure. Let's make this the last one. So which representation shows a proportional relationship between x and y? So I kind of already told you the answer to this. I told you that it had to go through the 0 coordinate when we talked about the other example. So A is no good because it doesn't do that. B is just a horizontal line, so it doesn't do that either. So now we're left with non-graphical choices here. But we also said that it was y equals mx. So is there, we know that represents slope, but it's basically a multiple. Is there some multiple, and not whole numbers, it could be a fraction or a decimal. Is there some multiple of x that will give us y? So here we have, it's times 4, right? Times 4, this is times 3, and this is times 2 something. So C is out. So we ruled that out, B and C, so the answer has to be that. So going from 2 to 3, and again, we're looking at multiplication only here. This is times 1.5, right? 4 times 1.5, 4 plus 2 is 6, cool. 8 plus 4 is that, and 12 plus 6 is 18. So the answer is D there. All right? So this might be new terminology to some of you guys. And again, the constant of proportionality, I mentioned the other thing. So this is a running theme on this exam that they have. And by the way, that's kind of the gotcha of some of these, that sometimes the test will get themed and kind of start using terminology or something you don't know more than once. So that's kind of the gotcha of some of this. All right, guys, I'm going to call it a day because my voice, I still need to talk for another hour and a half or 2 hours. So let me get rid of that there. Please smash the like button, guys, and I hope you guys have a wonderful Friday. Let me get my double P sign there. Double peace. All right, guys, peace out. Everybody have a good day. You guys can email me at GregsTutoringNYC@gmail.com. Yeah.